So in section 6, we're going to be working on applying the law of cosines. So we've learned the law of sines. And if you remember, the law of sines involved sine, obviously, and it involved creating a ratio between the sine of an angle and the length of the side opposite it. So when we worked with the law of sines, which is what I'm writing out here, it required that for us to use the law of sines, we needed to have a pair of angles and sides, so that we needed an angle and the side opposite. Now, when we don't have that, that's when we use the law of cosines. The law of cosines is a little more difficult to use, not a lot, but a little more difficult to use. And it's for cases where you can't use the law of sines. So when you're working on solving a triangle, your first hope would be that you could use the law of sines to solve it. And if you can't, then you'd move on and use the law of cosines. So the type of thing we might do with the information from this section is this idea here, where again we know, in this case we know three sides, and we'd like to know the area that is defined by the triangle that has sides of these lengths. And we'll learn how to do that in this section. So here's the law of cosines. So you'll see that it involves using all three parts, right, and one angle. So three sides and one angle are involved. So it works in the case of side angle side, where I have two sides and the angle between, because I don't ever have a pair, right? If I have, in this case, I have side B, but I don't have angle B. I have side C, but I don't have angle C. I have angle A, but I don't have side A. So I can't use the law of sines. So instead, I'm going to use the law of cosines. So in this case, I'm going to use the one that has the angle that I have. Okay, so I know that the A side squared will be equal to the B side squared, which would be 23 squared, plus the C side squared, which would be 26 squared, minus 2 times B times C times the cosine of angle A. Okay, so it ends up having a bunch of parts, and I'm going to pull out my calculator so I can do these parts. Okay, so I'm going to start with the addition part over here, and I'm going to do 23 squared plus 26 squared, and that's, oops, let me do this again. So I'm going to do 23 squared plus 26 squared, and that equals 1205. So I'm going to write down 1205. And then I'm going to have to do this other part. So I'm going to have 2 times 23 times 26 times the cosine of 114 equals, all right, so it's going to be minus a negative. Okay, so you do have to be careful about these things. This is minus 486.46. Okay, so minus a negative would be the same as adding. So I'll have 1205 plus 486.46. That equals 1691.46, and that's going to be a squared. I'll want the square root to get a, 41.13. So I know that a will be equal to 41.13. Okay, now that I have this length of a side, now I can use the law of cosines to finish finding the other things I need. So I now have a pair. So I know that the length, I'm actually going to be solving for an angle, so I want to have the sine of an angle in the numerator. Sine of 114 degrees divided by 41.13 will be equal to the sine of side, let's say C, sine of angle C divided by 26. So I'll multiply both sides of this equation by 26, and that will be equal to the sine of c. Then I'll be able to use the inverse sine function to find what c is. So let's go ahead and do that. So I'm taking the sine of 114, and then I'm dividing it by 41.13, and then I'm multiplying it times 26, and this is equal to the sine of c. So now if I do my inverse sine, I find that c is 35.27 degrees. So I'm going to find that angle C is 35.27 degrees. So over here, 35.27 degrees. Now, I don't really have to do this again. I know that my angles are going to add up to be 180. So all I have to do now is take 180 minus 114 minus 35.27, and I find that B is 30.73. 30.73, and now I've solved my triangle. Okay, so you notice I didn't use the law of cosines repeatedly. I used the law of cosines once, then I used the law of sines once, and then I found the remaining angle by subtracting the other two angles out of 180. Okay, so pretty simple. It's got a lot of steps, but each individual step is not too bad. Okay, so let's do another problem like that. So I have two sides and an angle. I happen to have the same two sides, so I have a squared will be equal to b squared, which is 15 squared, plus c squared, which is 24 squared, minus 2 times b times c times the cosine of a, which is 103 degrees. Okay, so again, I'm going to do this in pieces. So I'm going to do 15 squared plus 24 squared, and that's 801. So I'll have 801 minus, and now I'm going to do the other part. So I'll have 2 times 15 times 24 times the cosine of 103, 103 cosine. And again, I'm subtracting a negative number. So I have 161.96. I'm going to actually make it 0.97 because if I actually round it all the way out to here, it would round all the way up. So 161 minus negative 161.97. And so subtracting a negative again becomes like a positive. So I'm going to have 0.97 and 2 and 6 and 9. So 962.97. And if I want to take the square root of that, 962.97, and I take the square root, I get 31.03. So A will be equal to 31.03. So now I've got a side and the angle opposite. So I know that the sine of 103 divided by 31.03 will be equal to the sine of B divided by 15. So again, I multiply both sides by 15. And I'll have 103 sine divided by 31.03 equals times 15 equals, and then I'm going to do the inverse sine, and I get 28.1 degrees. 28.1 degrees. So if I take 180 degrees minus 28.1 degrees minus 103 degrees, I get 48.9 degrees. So I know that C would be equal to 48.9 degrees. Okay, I'm going to check a little bit for validity. Was A the longest side? Yes, it was. The next the next largest angle should have been C, and C is bigger than B. That makes sense. Side C is bigger than side B, so everything makes sense. So go ahead and practice the side angle side case on your own. Do problems 3 through 7. Those are some matching problems. Then practice 8 and 11. And then come back and we'll do side, side, side. So when I have 3 sides but no angles, I can still use the law of cosines, and I can use it for whatever angle I want. So let's say I want to find angle A. I know that A squared, which would be 25 squared, is equal to B squared, which is 24 squared, plus C squared, which is 19 squared, minus 2 times B times C times the cosine of A. So I ran out of a little space there. But I'm going to go ahead and use the calculator now to start simplifying some things. So I've got 25 squared, that's 625. So I know I have 625 over here is equal to, I'm going to have 24 squared plus 19 squared and that's equal to 937. Okay, and now I've got 2 times minus 2 times 24 times 19. Let's go ahead and do that. 2 times 24 times 19 equals 912. 912 times the cosine of A. So if I add 912 times the cosine of A to either side of the equation, and I subtract 625, I'm here. And then what I'm going to do, and I know that the cosine of A will be equal to 937 minus 625, all divided by 912. And when I use the inverse cosine function, I'll be able to find angle A. So let's go through these steps. Let's do 937 minus 625 equals 312, divided by 912. And this is the cosine of A. So if I now use the inverse cosine, A is 70 degrees. Okay, so angle A is equal to 70 degrees. Now, once I have an angle and the side opposite, I don't need to do the law of cosines anymore. I can do the law of sines. So I know that the sine of 70 degrees divided by side A, which is 25, will be equal to the sine of angle B divided by 23. And if I multiply both sides of this by 23, I'll be able to simplify this out and find angle B. So I have the sine of 70 degrees divided by 25 times 23 equals 0.86, and this is the sine of angle B. So now I do the inverse sine function, and I get 59.83 degrees. So I know that B is equal to, let me look at that again, 59.83 degrees. 59.83. Now I know that angle C will be equal to 180 minus 70 minus 59.83. Going to go ahead and do that with the calculator. So I'll have 180 minus 70 minus 59.83. And so angle C is 50.17. Okay, so I found angle A, angle C, and angle B. I've solved my triangle. Okay, again, I want to check for validity just in case. A was the biggest angle, side A must be the biggest side. It is. Then next would be B, it's the next biggest, and last would be C because it's the smallest angle. Everything checks out and looks quite valid. Okay, so go ahead and practice the side, side, side case. Do problems 13 and 14. come on back and we'll talk about area of a triangle. Okay, so in the last section we found a formula for the area of a triangle using sine, and here we're going to use Heron's formula, which uses three sides and the semi-perimeter. So S is the semi-perimeter, so it's half the perimeter, and we're going to use that in this case. So I know that my area will be equal to, well, I'm going to have to use S 3 times, so it's the semi-perimeter times the difference between each side and the semi-perimeter. So let's go ahead and find the semi-perimeter. So we'll have 49 plus 47 plus 58 all divided by 2. So 49 and 47 are 96. And 96 plus 58 would be 104 plus 50, 154. Divided by 2 is 77. Okay, so the area will be the square root of 77 times 77 minus side A, which is 47, times 77, minus side B, which is 58, times 77 minus side C, which is 49. Okay, so when I want to simplify this, it's 77 times 77 minus 47 is 30. 77 minus 58 is 19. And 77 minus 49 is going to be 8, 28. Okay, and now I'm going to go ahead and pull out my calculator, multiply these guys together, and take the square root. So I'll have 77 times 30 times 19 times 28 equals, and I take the square root, and so my area is going to be 1108.57. All right, so it's a pretty simple formula to use. You have to find the semi-perimeter, and then you have the semi-perimeter times the difference between the semi-perimeter and each of the sides. So multiply these four guys together, take the square root, and you'll find the area. So go ahead and practice that. Do problems 21 and 24, and then we'll solve our last problem. So if you take a look at this, they want me to find the area, and they've given me three sides. Okay, great, that's Heron's formula. So let's find the semi-perimeter. S will be equal to 170 plus 240 plus 350, all divided by 2. So let's go ahead and do that. So I'll have 170 plus 240 plus 350 is 760 divided by 2 is 380. Okay, so my semi-perimeter is equal to 380. Now when I want to find the area, it's going to be equal to the square root of the semi-perimeter, 380, times the semi-perimeter minus the first side, times the semi-perimeter minus the second side, times the semi-perimeter minus the third side, 350. Okay, and when I go ahead and I start simplifying this, I'll have 380 times 380 minus 170 is 210. 380 minus 240 is 140. And 380 minus 350 is just 30. Okay, so now if I want to pull out my calculator now, I'll have 380 times 210 times 140 times 30 equals, and then I'll take the square root. And my area is 48,944.83. So 48,944.83. 48,944.83. And this was in yards, so it'd be yards squared. Okay, Aaron's formula is pretty simple to use. And it helps me calculate area when I don't know anything about the angles and I just know the lengths of the sides. Okay, that's the end of chapter 9.